Okay, Assalamu alaikum warahmatullahi wabarakatuh. Today we are still in chapter 3. In our previous class, we learned how to integrate functions of hyperbolic functions and how to integrate if the integration including inverse trigonometric function or the formula of inverse trigonometric functions. And we learned how to complete the square. Okay, today we need to go for integrations that have inverse hyperbolic function, not inverse trigonometric function, inverse hyperbolic functions. But the idea is the same, the concept is the same. Okay, let's go for the formula we have. The derivative for sine inverse x equal to 1 over square root 1 plus x squared. This means the integration of 1 over square root 1 plus x squared equal to sine inverse x. Okay, the integration of 1 over square root x squared minus 1 equal to cos inverse x. This means that the derivative for cos inverse x is this formula or this value. So the integration for this value equal to cos inverse x. The integration of 1 over 1 minus x squared tangent inverse x. Tangent inverse x. Same like what we did for inverse trigonometric functions, we need to learn how to apply the formula to find integration. For example, if I have integration for square root a squared plus x squared, this means it is equal to sine inverse x over a plus constant. So I will concern more about these formulas here. The integration of 1 over square root a squared plus x squared sine inverse x over a. The integration of 1 over square root x squared minus a squared equal to cos inverse x over a. This is the more general formula. If a equal to 1, you will have cos inverse x. Here, if a equal to 1, you have sine inverse x. 1 over 1 minus a squared minus x squared equal to 1 over a tangent inverse x over a. Or 1 over a cos inverse x over a plus constant. This one, if modulus x less than a or modulus x greater than a. If a equal to 1, then we have tangent inverse x. Sec inverse and cosec inverse, we have square root a squared minus x squared here in the denominator, but multiplied by x. Multiplied by x. So if you have x outside here, this is usually either sec inverse or cosec inverse. It depends if you have under the square root a squared minus x squared or a squared plus x squared. So if you have 1 over x square root a squared minus x squared, then you have minus 1 over a sec inverse x over a. If you have 1 over x square root a squared plus x squared, this is minus 1 over a cosec inverse x over a plus constant. So these are the formula of sine inverse, cos inverse, tangent inverse, cos inverse, and sec inverse, cosec inverse. But how to integrate sine inverse itself? I mean, if I need to evaluate integration of sine inverse or integration of cos inverse or sec inverse, you need to apply either by parts or substitution, similar as what we did for integration of tan inverse last class. All the inverse function by the same way. Okay, now we need to use these formulas to solve these examples, here. Now we need to solve this integration. We need to solve this kind of integration. Integration of 1 over square root 3x squared plus 2. 1 over square root 3x squared plus 2. we need to integrate this one. Okay, this kind of integration using the formula. This kind of integration using the formula. Usually, if you have constant here, if you have constant in the numerator, and in below you have a square root, we have a square root or quadratic equation like this one, 3x squared plus 2. Maybe this quadratic equation under the square root or not. Usually, we apply one formula, either the formula of inverse trigonometric function or the formula of inverse hyperbolic function. How you know? Here you have a constant, here you have a quadratic equation, especially if you don't have x. This is a formula. If you have x, you need to complete the square first. So this is kind of the formula, but before going to decide which formula we have to use, I have to replace 3x squared by another variable square. 3x squared by another variable square. So here this one will be equal to, I will make t equal to square root of 3x. Why? Because I need to replace this one by t squared plus 2. I need to replace this one by t squared plus 2. So t should be square root of 3x. Then dt square root of 3 dx. dt square root of 3 dx. So here dx have to be replaced by dt over 1 over square root. dt over 1 square root of 3. Now we can apply the formulas. If we check back the formula, this is the formula of sine inverse t. This is the formula of sine inverse t. Okay, but here a square is 2. Then a itself is the square root of 2. A itself is the square root of 2. Means that sine inverse x over a, t over square root of 2. Sine inverse t over square root of 2. A square here is 2. This is t square plus a square. This is the formula of sine inverse. A square is 2, then a square root of 2. We cannot stop here. I have to write back my integration in terms of x. This one. These are the formula that we use. I have 1 over square root a square plus x square. If you have this kind of integration, the answer is sine inverse, x over a. If you have square root x square minus a square, the answer is cosh inverse x over a. If you have 1 over a square minus x square without the square root, then you have tangent inverse or cos inverse. It depends on the modulus of x. If you have x outside, multiplied by the square root a square minus x square, you have sec inverse. This is the integration of sec inverse. This is the formula of integration of cosec inverse. This formula we provide to you in the test, but you need to know how to apply. Usually, if you have constant here, if I have a fraction, in the numerator you have a constant, below you have a quadratic equation without x or with x, but if you have x, you need to complete the square. But if you don't have x, like this one, a square plus x square minus a square, these are quadratic formula. So this is integration either using the formulas of inverse trigonometric function or the formula of inverse hyperbolic function. Usually you should have constant. Below is the quadratic equation without x. If you have x, you need to complete the square to cancel x. Cosec inverse, sec inverse, same. Constant here, quadratic equation without x, but outside the square root, you multiply by x itself. So only sec inverse, cosec inverse having x outside the square root. This formula that I apply. So now when I have the integration for this part, for this question, I change this one to t squared plus 2. So t squared plus 2 is similar to this one, but a squared is 2. A squared equal to. Okay, so here I use this formula of sine inverse. So 3x squared become t squared plus 2. Plus 2. So you have sine inverse. You have sine inverse t squared over t over square root of 2. T over square root of 2. You cannot stop here. You have to write back your integration in terms of x. So square root of 3x over 2 plus constant. So this is the first integration. Okay, the second integration, dx over x square root 9 minus 4x squared. Dx over x square root 9 minus 4x squared. So this is equal to. Now this one, similar to formula of sec inverse and cosec inverse. How I know? Because here I have a constant. The most important thing to use the formula, be sure in the top you have a constant. If in the top you have x or x squared or any variable, you cannot apply the formulas. But here you have constant. Okay, what I have below, I have square root. Outside the square root, we have x. Below the square root, I have a quadratic equation. So this is kind of the formula. This kind of formula usually sec square or cosec square. Why? Because only cosec and sec square have x multiplied outside. So how to apply this one? I need to arrange, because here I have 4x squared. I need to be a variable square only. So I need to make t equal to x. Then dt is 2 dx. So integration 9 minus t squared. Okay, x itself, because I need x to change to t. So t equal to x means that x t over 2. So x here, t over 2. Okay, what about dx? Dx equal 1 over 2 dt. The 1 over 2 here will cancel with 1 over 2. So integration is dt over t square root 9 minus t square. Dt over t 9 minus t square. This one, if I go back to the formula, it will be sec inverse. If I go back to the formula, if you check the formula that you have, it is sec inverse x. So the formula of sec inverse x is like this one. If you have dx over x a square minus x squared, this is equal to minus 1 over a sec inverse x over a. This is the formula of sec inverse. So I will use this one here, because here I have t 9 minus t squared, same like this one. So a here, or a square, is 9. So a is 1 over 3. So based on the formula, this is minus 1 over 3 sec inverse t over 3 plus constant. Minus 1 over 3 sec inverse t over 3. So this is the answer of our question. So this means that it is equal to minus 1 over 3 sec inverse t was equal to 2x. t is 2x. So 2x over 3 plus constant. 2x over 3 plus constant minus 1 over 3. Check inverse 2x over 3 plus constant. One more example. Integration of the x over square root 2x minus 3 square plus 1. So integration of the x over 2x minus 3 square plus 1. I need to find the integration here. Okay, when I have this kind of integration from the beginning, I know this integration will be solved by formula. How I know? Here I have a constant, I have a fraction. In the top, I have a constant. And below, we have a quadratic equation. So this kind of one of the formula. Which formula? I need to arrange my integration first. Okay, any formula, this, yes,
Shining first.
this one is a quadratic equation. So what I need to do, how I know this is a formula, this one is a constant here. This one is a quadratic equation. This one. You have square plus constant. Is that your question?
We let
Yeah, we need to let, I will use substitution
x.
here.
Yeah.
Okay. So here I will use substitution because all this one have to change to t squared. We cannot multiply by any number. So t here should be square root of 2x minus 3. Square root of 2x minus 3. Why? Because all this part have to be t squared plus 1. So all this part have to change by t squared. So t itself is square root of 2x minus 3. Then dt is square root of 2 dx. Square root of 2 dx. So 1 over square root of 2 outside dt. 1 over square root of 2 dt over square root t square plus 1. So 1 over square root of 2, this is the formula of sine inverse. Here a square is 1, then a also 1. So sine inverse t plus constant. Sine inverse t plus constant. You cannot stop here. You have to write back your integration in terms of x. Sine inverse square root of 2x minus 3 plus constant. So again, here how to use the formula. I need to be sure here that x squared not multiplied by any number. And you should be sure that you have x squared or variable square, not x minus 3. So what you need to do, all this value here have to be replaced by t squared. All this value have to be replaced by t squared. So if t squared equal to x minus 3 squared, this means t itself square root of 2x minus 3. Then you can go for substitution and find the answer. How to check your answer? Find the derivative for this function. It should be equal to this one. Find the derivative of this function. D here, integration dx over square root x squared plus 4x plus We have integration dx over square root x squared plus 4x plus 3. Okay, this also is a kind of the formula. How I know? Because we have constant here and quadratic equation under the square root. So we need to apply the formula. But before applying the formula, I have to complete the square first. Why? Because I have x now. Not only x squared and the constant. We have x in the middle. So we need to cancel this x first. How we can do that? Only by completing the square. Only by completing the square. So we need to complete the square first. X squared for x plus 3. A is equal to 1. B is equal to 4. C is equal to 3. So need to evaluate b squared over 4a. B squared over 4a. B squared is 16 over 4 times 1, which means 4. Which means equal to 4. 16 over 4. Okay, so you have to add 4 minus 4. So x squared plus 4x plus 3 plus 4 minus 4. Plus 4 minus 4. Now x squared plus 4x and the number I add is a complete square. It is equal to x plus 2 square. Plus 3 and minus 4 is minus 1. Plus 3 and minus 4 is minus 1. So x plus 2 square minus 1. So this is the integration of dx over. Now instead of the quadratic equation x squared plus 4x plus 3, then x plus 2 square, this is a complete square, minus 1. Minus 1. Now we don't have x. Now we need to apply the formula. But x plus 2 have to be replaced by t square. So we will have square root t square minus 1 by making t equal to x minus 2. I will let t x plus 2, sorry. X plus 2. So x plus 2 square is replaced by t square. Then dt will be equal to dx. dt is equal to dx. So here dt. So dt over square root t square minus 1. So all this one is replaced by t square. T square minus 1. So this is a kind of the formula. We need to check back which formula we need to use. If you go back and check, this is the formula of cosh inverse. This is the formula of cosh inverse because cosh inverse formula is the x over x square minus a square equal to cosh inverse x over a. So here this is cosh inverse. Here a square is 1. So a is also 1. Then cosh inverse t plus constant. Write it back in terms of x. Then cosh inverse t here is x plus 2. X plus 2. Some student can make directly this one by cosh inverse x plus 2 plus constant, also correct. Some student can know directly, so can, without substitution, they directly write it is equal to cosh inverse x plus 2. Also correct, also can. Or you can use substitution. The most important thing, the formula To apply, you should have constant here. Here, a quadratic equation without x. So if you have x, you need to complete the square. You have to complete the square. After you complete the square, then you can apply the formula. Now we need to solve this one. We need to show that the integration of x plus 1 over square root x squared plus 1 equal to this value. Equal to this one. So how to integrate this part? X squared over square root x squared plus 1. How to integrate this one? We have to split the fraction. Okay, here this one, x plus 1 over square root x squared plus 1 dx equal to the integration x over x squared plus 1 plus dx plus 1 over square root x squared plus 1 dx. So this fraction can be divided into two fractions. The first one, x over square root. The second one, 1 over square root x squared plus 1. Now this part, x over square root x squared plus 1, not a formula because you have x here, not constant. If you have a constant like this one, constant, this is one of the formula. But this one, we have to use substitution method. We have, because I have a quadratic equation, here we have x. So this is substitution method. So if I go for the first integration, now I need to integrate this one. X over x squared plus 1 dx. If you take t, x squared plus 1, then dt is 2x dx. So 1 over 2 dt is over square root of t. Okay, x squared plus 1 is replaced by t. X dx is 1 over 2 dt. 1 over 2 dt. So here this one equal 1 over 2 is a constant. Integration of 1 over square root of t as a power function. This is t over to the power minus 1 over 2. So plus 1 t over 1 over 2 divided by the new power 1 over 2. Because minus 1 over 2 plus 1 is 1 over 2 plus constant. So this one cancel with this one. So square root of t plus constant. So this one square root of x squared plus 1. Square root of x squared plus 1. Our substitution. So this part is by substitution. This part is a formula. This one is a formula of sine inverse x. Here you have a constant. Here you have a quadratic equation. This x squared not multiplied by any number. So this integration is ready to use by formula. Is ready to use by formula. So integration of x plus 1 over x squared plus 1 dx equal to x squared plus 1, the integration, plus equal to this integration plus the value of the second integration. This one is sine inverse x plus sine inverse x plus constant. Sine inverse x plus constant. So here we split because easier for me instead of the integration directly to split the integration into two integration. in the doing derivation. By this, we end chapter 3.